Hi, my name is Brenda Lee, and I am working under the guidance of my mentors, Dr. Heidi Van Ravenhorst-Bell and Dr. Janelle Petrosor. The topic I am presenting on today is the impact of youth sports on physical fitness into adulthood. Youth sports is known to promote activity and reduce the risk of disease. As a result, it can lower the rate of obesity and cardiac issues, which lowers the mortality rates. It can promote long-term commitment towards health and fitness, which helps youth to be more consistent in doing their physical activity, and it can enhance quality of life and daily function, which helps to maintain a state of health and well-being. A few of the key terms I will need to define before we move on is VO2 max, which is the maximum amount of oxygen an individual can uptake during intense exercise. Submaximal VO2 is a prediction of the VO2 max using lower intensity exercise. The submaximal measure we are using for this study is the 1.5-mile run and walk test. And cardiorespiratory fitness, which is the use of oxygen to produce energy during physical activity via the circulatory and respiratory systems. For this study, we had two hypotheses. We hypothesized that adults with youth sports background will have a higher VO2 max than adults with no sports background. We also hypothesized that adults with youth sports backgrounds are more likely to continue being physically active than adults with no sports background. For our methods, we have split it up into a few different components: the participants, the intake process, and the procedures. For the participants, we recruited 35 healthy young adults aged 18 years old or older through flyers, social media communications, and word of mouth. The mean age was 22.94 years old. So the way in which we decided to categorize these participants were in two groups: sport youth and non-sport youth. For sport youth, this included everyone who participated in at least one organized sport up until the age of 18. For non-sport youth, this included everyone who didn't participate in sports up till the age of 18. We also had one participant who withdrew from the study before we could collect their data. Therefore, their results were not included. For the intake process, each volunteer was asked to fill out an informed consent form. We wanted to make sure the study had participants who were completely healthy, so they had to fill out what we call a PARQ+, and this stands for the Physical Activity Readiness Questionnaire. This determined that they had no neurological, muscular, orthopedic, or cardiovascular conditions. They were then asked to fill out a fitness questionnaire, which asked them if they played youth sports, as well as if they are active as an adult currently, from their activity levels based on sedentary all the way to vigorous. For the procedure, their age, gender, height, and weight were recorded. They were then given a polar heart rate monitor, which included a chest strap that was fitted to their mid-trunk, and they were also given a watch that linked to this chest strap, and it shows their heart rate. Before any kind of physical activity was done, we measured their resting heart rate. Then we moved straight into their dynamic stretches to reduce the risk of injury, and we had them each do this for a minute each, and this included the knee hugs, butt kicks, toe touch kicks, and over-under steps. Following this, we had them run the 1.5-mile walk and run test, and they had to do this in the fastest time possible. Following this test, they had to take their post-exercise heart rate, and we used this to figure out what their estimated VO2 max is, and here's the standardized equation. For the statistical analysis, we use SPSS version 23. Of this, we did two analyses. One was ANOVA, and this stands for a one-way analysis of variance. And this basically determines if there's a significant difference in dependent variables. In our case, it would be VO2 max estimated between sport and non-sport youth. We also did a further analysis called the regression analysis, and this determines if participation in youth sports is a reliable predictor of an adult's continuation of physical activity. And for all of the analysis, the alpha level was set at p is less than or equals to 0.05. For our results for ANOVA, it was found that our VO2 results between active youth and non-active youth were significantly different. Our effect size was strong at 0.23, meaning we had enough participants for the study to come to the conclusion that our results were significantly different. Our observed value was also strong at 0.85, meaning that we are confident in the results of the study and it has a good chance of being replicated with similar results. So as we can see in this table here, the VO2 max average of active youth and the VO2 average of non-active youth. Active youth had an average VO2 of 38.20, and non-active youth had an average of 28.79. So we can already see that there is a notable difference between these two variables. For our bivariate regression analysis, this was also found to be significant with a moderate relationship of R equals 0.64 on predicting the continuation of physical activity into adulthood. This means that adults who participated in childhood sports were more likely to remain physically active as an adult as compared to those who didn't play sports at all. So as we can see in this bar chart here, specifically under the label of adults, 15 of the 19 sports participants remained physically active into adulthood, whereas less than 5 of them became physically active into adulthood. So based on our results, the findings of this study support the promotion of youth sports in these ways. Our estimated VO2 max between active youth and non-active youth differed by nearly 10 milliliters per kilograms per minute. From here, they are able to maintain a healthier cardiovascular fitness into adulthood, and they are able to easier build dedication and commitment to physical activity lasting through adulthood. So just how big a difference does 10 milliliters per kilograms per minute make? Well, as we can see here, according to the maximal oxygen uptake norms for both women and for men, these tables show that there is quite a large difference. So in the previous slide, we know that the non-active youth had an average VO2 of 28, and the active youth had an average VO2 of 38. So for women, because our mean age was 22, 28 would be considered a poor classification level, and 38 would be considered average. So right here we can see it's already jumped up by 2 classification levels, and that's the same for men. It jumped from very poor to below average. And that's just based off of the fact that some people played youth sports and some people did not. We had a few limitations for the study as well. We had a small sample size of 34 participants. We also did not utilize the gold standard method of calculating true VO2 max, although in our future studies, we could definitely implement true VO2 to make our results slightly more accurate. And for group categorization, we only had 2 categories, which was sport youth and non-sport youth. In future studies, we could implement more variables, such as the type of sport played, also the length of time they played the sport for, as well as narrowing down any age groups. For our future application, because our study had support that youth sports have a beneficial impact on adults' physical fitness, coaches and health professionals could advocate more in schools for youth sports. More school organizations could be implemented to provide more opportunities for underserved youth, as there is quite a barrier, such as fees to be in the sport or cost of equipment, which can slowly add up over time and prevent youth from staying in their sport. Not only will more children be introduced with sports, but they will be introduced in a stimulating and fun way. And this will help to retain more individuals in youth sports and maintain their cardiorespiratory fitness into adulthood. In conclusion, the introduction of sport in youth is shown to be beneficial in promoting healthy cardiovascular measures and maintaining physical activity across ages. This may reduce the risk of disease and improve overall quality of life. With that, here are my references. I am open to answering any questions. So for age and gender, we didn't really calculate or we didn't distinguish them. We just lumped them all together. So despite the fact that they were male or female, we just lumped them all together. So we didn't look into that. We just looked into their average and we clumped them all together. For their age, they were all college students, so we didn't have a lot of difference there either. Like the difference between non-active youth and active youth, they were very close. For active youth, their mean age was 22.94 years old, and for non-active youth, it was 22.93 years old. So there wasn't too much difference there. I think that's one of the limitations as well. We could add more adults. That's one of our limitations because we didn't narrow down the age grouping. We just lumped them all together. We can promote more activity and sports to youth. Like I said, it would be good if more coaches and health professionals could provide more of those opportunities for those youth in schools. I know that in PE classes, they don't last too long, so If there was more programs that could include more students into it, that would be nice as well as more of the free programs for underserved youth.